I want to talk about problem 2.23 of Carver and Thomas, second edition. The reason that I prepared this note is that I noticed that many students have turned in homeworks number 2, which have students have made mistakes or provided incomplete solutions on this problem. Thus, I made this discussion note, so you guys can learn from these notes and do not repeat the mistake. Okay. Right. So, problem 2.23 is finding the mutual information of this form. Okay, and the problem statement goes like this: consider a sequence of n binary random variables, x1, x2, xn. Each sequence with an even number of ones have probability 2 to the minus n minus 1. And each sequence with odd number of ones have a probability 0. So given this probability distribution, basically a joint distribution on these random variables, what we need to do is to find the mutual information between x1 and x2, x2, x3 given x1, and so on, all the way up to this expression. So mutual information between the two last random variables given the first n minus 2 random variables. Okay, so that is the problem. And here is my solution. Note that it is given that each sequence with an even number of ones has the joint probability. So probability goes like this. Okay, x is the vector of length n, and its samples x1, x2, xn. So these are the realization of random variables. So you can treat these as numbers, ones and zeros, basically. And then this n tuple have even number of ones, then probability of such event is described to be, is given to be 2 to the minus power of n minus 1. So each sequence with the even number of ones have the same probability. And note that there are such sequences, and there are this many such sequences, let's say 2 to the power of n minus 1 such sequences. For example, if n is equal to 3, the length of the sequence, length of each sequence is 3, and probability of each event where there are even number of ones is 2 to the minus 3 minus 1, which is 2. So it is 1 over 4. Probability of even sequences is 1 over 4. All have the same probability. So each one has the same probability. And since there are 4 such sequences, basically when you sum them all up, the probability equals 1. And then since sum of even sequences is equal to 1, the probability of sum of probabilities of even sequence is 1. Basically, probability of odd sequence has 0 probability. Okay. So for a fixed n, what is given here is the joint distribution, basically. So having said this, for a fixed length, we know all the joint distribution. I mean, all the elements of the joint distribution. Okay. We need to, from this joint distribution, we need to derive the marginal distributions to calculate the mutual information from this joint distribution. So let's have some examples. So let n is equal to 2. All right. So length 2 sequence. And we consider mutual information between x1 and x2. All possible outcomes for x1 and x2 are 0, 0, 0, 1, 1, 0, 1, 1. Then from 1.2, which is that probability of even sequence is 2 to the power of minus n minus 1 power. So n is equal to 2. So that probability is when you have an even number of ones, which is in this case, since both of them are zeros, so that is the even number of ones. So this probability is 1 over 2. And the probability of 1, 1 is also even number of ones, so it is 1 over 2 as well. Probability of 1 and 0, since this is even number of ones, the probability is 0. Same goes for this odd case as well. So the probability is 0. So what you are given with is the joint distribution. From this joint distribution, you need to derive marginal distribution and the conditional distribution and so on. So the marginal distribution in this case is nothing but px1. For the case of px1 is px1 is equal to 0 is half. Why? Because this is the px1 is equal to 0 when x2 is equal to 0, and then another one is right here, 0, px1 is equal to 0, and then x2 is equal to 1. So you add these two probabilities to obtain px1 equal to 0, which is half. Okay, the same goes for x1 is equal to 1. So you add this probability with this one, where both you have, in both probability, you have x1 is equal to 1, and then x2 is 1 or 0. So that probability you add up, then it is equal to half. So as you can see from here, this distribution is uniform. And then the same goes for the marginal distribution for x2, which is half and half. Thus, the product distribution in this case is product of x1 and x2, which is uniform. So note in this case that the two random variables, x1 and x2, are not independent. Okay, so once the distribution, joint distribution and the product distribution are given, it is just a matter of applying the definition to calculate the mutual information. So mutual information can be defined as relative entropy between joint distribution and product distribution. And then we apply that to this definition. Then we note that the joint distribution is non-zero only when we have even number of ones in this sequence. So whatever you have here doesn't matter if you multiply with a zero probability. So what we have left with in the next line is 0, 0, and 1, 1 cases only. So probability of this is half, and we take the ratio of the joint versus the product distribution. For the case of 0, 0, then that one is half, this one is quarter, so that's the ratio. And then for the case of 1, 1, this probability is half, that is half, and this one is quarter again, the product distribution. So for both cases, the ratio are the same. Ratio is the same for each case. And this probability, joint probability, is also the same, half. So we have two such terms, so we multiply with the 2, half, which is this probability, and then log of the ratio. And this ratio is nothing but 2. So log 2 of 2, and that is equal to 1. So we have the first result, and this result tells us a lot. Okay. So we made a big progress, and then we understand what it means to have the joint distribution and derive the marginal distribution from that. Okay. And there are other ways to get these answers, but this is one answer that we can do. And let us now consider n is equal to 3 case. And consider, in this case, mutual information between x2 and x3 given x1. So again, we have to start with the joint distribution that is given and find out other marginal distributions and the conditional distributions as well. So all possible outcomes we consider first for x1, x2, x3 for the length 3 sequence. So there are 8 of them. So as we note that x1 is set equal to 0 here, and then 1 here, 0 for x2, 1, 0, and 1. For x3, 0, 1, 0, 1, 0, 1, 0, 1. So we have all 8 possible cases, possible outcomes written right here. And then we consider the probability distribution. Okay. So what is the probability of a sequence of 0, 0, 0? So this is even number of ones, so that is 1/4. When you have odd number of 1, it is 0, 0. Even number of 1, 1/4. Odd 0, even 1/4, even 1/4, odd 0. So we have the joint distribution clearly defined. Okay, now given this, we can find out the conditional distribution between the conditional joint distribution. So joint between x2 and x3, given x1. Okay, so x1 is given in this case to be 0, and then in such a case 0, 0 is half, 1, 1 is half. Okay, and in this case we have a probability assignment of zeros. And then when we have 1, then this conditional joint distribution, since x1 is 1, you know, the x2 and x3 in this part, we have to have odd number of ones, and that is these cases. So these cases we have half, and these cases where you have an even number of ones, the probability is 0. So that is the conditional joint distribution, and then here is the conditional product distribution. And then in this case, when you consider each one of these conditional distribution, let's say px2 given x1, px3 given x1, they are all half for each and every cases. So for example, x2 is equal to 0, given x1 is equal to 0, and then x3 is equal to 1, and x1 is equal to 0. So just following this notation right here, then you have a half and half product, which is 1/4. All right, how do you get it? So here is the derivation for this part. So px2 given x1, okay? So px2 given x1 can be obtained utilizing this one that we have calculated already, the joint distribution. So using total probability theorem, you consider x3 is equal to 0, x3 is equal to 1, and then reading off from this table right here. So what is this one here? Px2 is equal to 0, x3 0, x1 0. So that is this case, right? Half. Okay, the first one is half. And then what about the second one? So x1 0, x2 0, x3 1. x1 0, okay, and x2 to be 0. So 0, 0, x3 1. So that is this case, which is 0. So that is 0. So half plus 0 is half. And then you can continue on with the rest of them. All came out to be half. And that is for this case. So for each case, it is half all the times. And when you consider x3 given x1, probability of such event, also it came out to be half for all cases. So no matter which combination you have, each one is half. And then the answer, the product distribution, answer for the product distribution is just 1/4 for each cases.